Welcome to This Explainer. Look, if you're trying to break into the tech field right now, you are literally bombarded with terms like AI, machine learning, deep learning, and generative AI, the whole shebang. But when it's time to actually apply for a job, you suddenly hit a wall of titles: data analyst, data scientist, and AI engineer. Honestly, they sound super similar, right? But as you'll see, their day-to-day realities couldn't be more different. We are going to break down the exact differences between these three heavy hitters. So let's kick things off with the ultimate question you've probably been wrestling with. Which of these data careers is actually right for you? It's a massive decision. Picking the wrong path, that can mean spending years grinding through the wrong syllabus or just dreading your everyday tasks. We're going to clear up this confusion once and for all. To answer that systematically, we've got a solid game plan. We'll walk through the AI product pipeline, break down the data analyst, the data scientist, and the AI engineer, compare their salaries, and finally help you choose your path based on the exact syllabus, skills required, and job responsibilities for each one. All right, jumping right into Section 1, the AI product pipeline. Basically, the 6-step assembly line of tech. Before we can even talk about the jobs, we kind of need to understand the playground, right? Think of building an AI product like a giant manufacturing assembly line. First up, data collection. This is extracting raw data from databases, usually hitting it with some SQL. Step 2 is cleaning and pre-processing. Look, raw data is notoriously messy, missing values, crazy outliers, so it has to be scrubbed and standardized using Python. Step 3 is exploratory data analysis, or EDA. This is where we put on our detective hats, like noticing Amazon's sales spike during a very specific local event. Step 4, feature engineering. That's creating brand new inputs out of the existing data so our models learn faster. Then, step 5 is model selection, training, and evaluation. We actually teach the algorithm to make decisions and rigorously test it against fresh data. And finally, step 6 is deployment, taking that polished model out of the lab and putting it into the real world for actual users to interact with. Okay, moving to Section 2, role number 1, the data analyst, or as I like to call them, the business storyteller. So, a data analyst steps onto this assembly line for just the first 3 steps: collecting, cleaning, and exploring. Their main mission: extracting golden nuggets of insight to help leadership make big business moves. Say a CEO needs to know monthly sales or figure out exactly why customers keep ditching their shopping carts right before paying. A customer churn report. The data analyst digs in to find out why. To pull this off, they rely heavily on SQL and Excel to extract the data, and then they use awesome visualization tools like Power BI or Tableau to turn all those boring numbers into interactive, beautiful dashboards. And the great news? The syllabus for an analyst is highly approachable. You're really only looking at low to moderate math and coding skills. You definitely need a basic grasp of stats and some introductory Python. But hey, nobody expects you to be a theoretical math wizard or a hardcore backend developer writing thousands of lines of code. It's the perfect sweet spot if you want to intimately drive business strategy using data without getting buried in heavy engineering. Next up, Section 3, role number 2, the data scientist, aka the model builder. Now, while the analyst tags out at step 3, data scientists go way deeper. They own steps 1 through 6 of the pipeline. They aren't just looking at the past, they're using it to build predictive machine learning models for the future. We're talking real-world magic here. If Paytm is building an automated credit card fraud detection system, or Netflix is crafting that perfectly addictive movie recommendation engine, the data scientist is the architect. They drop the heavy reliance on visualization tools like Power BI and swap them for heavy-hitting Python libraries: NumPy and Pandas for crunching data, Matplotlib and Seaborn for plotting, and crucially, scikit-learn for actually building those robust machine learning algorithms. But spoiler alert, this is where the syllabus gets pretty intense. To really grasp the underlying logic of these algorithms, you absolutely have to master 4 core pillars of math: linear algebra, statistics, differential calculus, and probability. You can't just plug and play a ready-made algorithm. You need to know the intricate math under the hood so you can tweak it, optimize it, and fix it when things inevitably break. So, unlike the analyst, the data scientist deals with a moderate to high math requirement, especially if you get into cutting-edge research-heavy work. Throw in a solid, moderate coding requirement too. You've got to be super comfortable writing clean, modular Python scripts to wrangle massive gigabyte-level datasets and train models on remote servers. All right, let's hit Section 4, role number 3, the AI engineer or the product developer. AI engineers tackle all 7 steps of the pipeline, start to finish. Actually, they're like a mutant hybrid between a data scientist and a traditional software engineer.
While data scientists focus heavily on traditional machine learning, AI engineers are out there on the absolute bleeding edge. Deep learning, neural networks, generative AI, that's their jam. They're the ones building massive systems like ChatGPT or real-time facial recognition software. To do this, they lean on advanced frameworks like PyTorch or TensorFlow. And here's the kicker. They don't just build a model in a notebook and stop. They wrap it into robust APIs and deploy it to cloud infrastructure so millions of people can use it at the same time without the whole thing crashing.
Because they are literally building and shipping hardcore products, the AI engineer syllabus is a beast. You need moderate to high math skills to intuitively grasp crazy neural network architectures and backpropagation. But the coding, that requirement is sky high. In fact, top-tier companies expect AI engineers to know data structures and algorithms just as well as traditional software developers. Writing highly efficient, memory-safe, scalable code is absolutely mandatory at this level. Okay, let's jump into Section 5, comparing salary packages, the fresher matrix. Let's talk about the numbers, because I know you've been waiting for this. How do these different job responsibilities, skills required, and tough syllabuses translate into actual cash? Looking at average starting packages for freshers in India, measured in lakhs per annum, it makes a ton of sense. Data analysts generally land between 4 to 6 LPA. Data scientists, bringing in that heavier math and predictive modeling, bump up to a range of 5 to 10 LPA. And then at the top of the food chain, AI engineers command a premium of 6 to 12 LPA, thanks to that rare blend of software engineering and deep learning skills. Now, obviously, these are baseline averages. Your actual paycheck is going to depend heavily on your specific skills, your city, the company tier, and your practical project portfolio. Which brings us to Section 6, choosing your career path by aligning your interests. So, we've mapped out the pipeline, the syllabus, the tools, and the money. How do you actually pick? It's all about aligning what you naturally enjoy with the day-to-day reality of the role. If you love business strategy and finding hidden trends, but you kind of hate writing heavy code or doing complex calculus every day, aggressively target the data analyst role. If you're a total math nerd who loves the theory of machine learning and solving real-world problems with predictive models, data scientist has your name on it. But if you're someone who loves building full-blown software products, enjoys heavy coding, and wants to live on the bleeding edge of neural networks and Gen AI, then AI engineer is 100% your path. But listen, regardless of which path you pick, there's one massive takeaway from our sources today that you simply cannot ignore. In this highly practical, fast-moving field, your skills matter way, way more than the title on your degree. Seriously, don't fall into the trap of thinking a specialized AI degree automatically hands you a job over someone with a general IT background. It doesn't. What the industry actually cares about is proof. You gotta focus intensely on building practical skills, snagging real-world internships, and most importantly, having at least 3 killer, high-level, unique projects on your resume that prove to a hiring manager you can actually do the work. So, you've got the map. You know the exact syllabus, the skills required, the job responsibilities, and the salary packages for the analyst, the scientist, and the engineer. The jargon can't hold you back anymore. So what's it going to be? Which of these 3 paths are you going to choose to start building your next big project? Keep learning, keep building, and I will catch you in the next explainer.